Oh, this battery. I made already other batteries, aluminium and steel, but it was with other type of aluminium. This is the first time I'm going to use a can, an empty can. So the idea is to get this steel and just put inside the can. And I'm not going to use this first aluminum steel battery using a can. I'm not going to use salts like Epsom salt. I'm going to try sodium hydroxide. So it will be tap water and a little bit of sodium hydroxide, and then I'm going to see how the oscillator I made reacts to this battery, how much voltage I get from this, and if it can drive the oscillator. So to make the battery, I just get two pieces of paper, kitchen paper, and stretch a little bit the steel so it can be the size of the can. Put it on here. I'll just put like this in here, and let's just wrap around the paper like this on the steel. So I have enough steel here to put the alligator clips. Get the can. The steel goes inside. Let's make it nice. And now I'm going to fill it with tap water and put a little bit of sodium hydroxide and see how much voltage I get from the battery. Now the can is filled with tap water, and the voltage we get just from the can, the aluminium and the steel, just with tap water, it's about 450 millivolts. As in the test with the oscillator, we need at least 559, better 560 to make it round. So we are with 475 without the sodium hydroxide. This is the sodium hydroxide I have here. You have to be very careful when dealing with sodium hydroxide. Take care not to burn your skin, and take very care with your eyes. So let's open this. This is the sodium hydroxide. The voltage on the battery is here. Let me try to put everything inside the frame. Okay, and I'll put a little bit of the sodium hydroxide into the water. Let's see how it will go. So here we go. Let me put a little bit, just a few drops. 1, 2, 3, 4, 5, 6, and a little more. Okay, and let's see what happens. Well, still 450 millivolts, not much. Let's shake this a little bit. Let's shake this water a little bit just to make sure the sodium hydroxide is dissolved in here. Let's measure again. The negative is the can and the positive is the steel. The voltage dropped to less than 100 millivolts. It's rising. $200. Let's try to put a little more of sodium hydroxide. Here. Okay. And let's try to put the sodium hydroxide on the outside of the can, where the water is in touch with the aluminum, not the steel. So there goes sodium hydroxide. A little more. Now we got 640. Let's try to put more. 800. there it goes. More sodium hydroxide, 1 volt. .1, and let's put the sodium hydroxide on all the sides. Here is in one side. Now let's put it on the other side of the can. We are now with 1.1 volt. Okay, more sodium hydroxide. 1.1. Okay, I think it's enough for sodium hydroxide. .3. Now we are with 1.272 volts. That may be enough to run our oscillator. Let's check if the oscillator can run with that voltage. Let's go back here to our oscillator. The voltage is in here. Let me put the LED here. The oscillator. The LED, and let's connect the positive of the steel and the negative. We are with 1.2 volts, and it dropped very much. 500, climbing. 539, 540, 45, 46, 48, 550. We need 559. 551. We still do not have enough power to light up the LED. We need 559 at minimum. Let me disconnect this the voltage gets back to 1.2 volts. Let's see if it flashes the LED. No, it don't flashes the LED. It's not enough to flash the LED. Let me try another oscillator. Okay, this one is another oscillator. There is no coil, just the inductor. We are with 1.2 volts, and let's see if it blinks. Now it gets to 200 millivolts. So we have enough voltage, but we don't have amperage. So the battery generates 1.2 volts, but it's very weak on milliamps. I'll try to add another component. This is sodium, I don't know what its name is, percarbonate. It's a whitening product for clothes that produces oxygen. I'll just put a little bit on the water. Let's see what happens. Now we have 6. I see some lights on the oscillator, and the voltage is rising a little bit. Let's shake the water. It seems that with this sodium I have to see the name of this product in English. Now this other oscillator is on. Let's try to get back to the oscillator we created before. You are off. Take this out, and let's get the oscillator. The negative cable is here. Let's plug. Now we have 1.4 volts, and we still do not have enough power on the battery. 5 to 5, 5.3, 5.4, 5.5, 5.2, 3, let's put more of this other product. Let's just add a little more and see what happens. Now again I will put on the aluminum side, not on the steel side. So there it goes. And a little more on the steel side. Let's shake a little bit. 5, 5, 6, 7, 8, 9. Something. Now I see a blinking. 2, 3, 5, 5, 5, 6, 7. 5, 5, 5, 5, 5, 6. Yeah, this battery does not generate a lot of power. So the next step is to create a salt battery. Let me shake a little bit. Oh, now I have the blinking. 7, 5, 5, 7, 8, 5, 5, 9. No. I'm going to do another test. Let's just charge a little bit this battery. The aluminum steel is a rechargeable battery, so maybe if we charge a little bit, it can it may generate electricity. We have 1.3 volts without any load. So let me see here. Here, let me disconnect all the wirings, and let's try to give a little bit of charge. Okay, negative and positive. So we have here positive on the positive, and let's charge a little bit this. Let's see how we are. Positive here, negative in here. We are with 1.5, 1.4 volts. Let's charge a little bit again. One 1.8. Now 1.7 volts. And let's connect the oscillator. Here we have the negative. Let's connect the positive, 1.5. Yeah, now we have the blinking. So with a little help from a charge, a small charge, and steel and aluminum begins to get stronger. So let me see how long it will run like this. Now it's 4 a.m. 5, almost 4 a.m. It's getting weaker. Let me make some tests. Now this is almost done. The oscillator we built is working fine with two orange LEDs in parallel. The 360k ohm resistor in parallel with the capacitor, it's working fine. The battery, the aluminum can, and the steel, it's now mixed with tap water, sodium hydroxide, and percarbonate, sodium percarbonate. This is holding the charge. Okay, and we are with 700 milliamps. So it's almost done. I just have to find a nice spec for the oscillator, a way to wrap the oscillator into the can, or maybe on the top of the can. And this is our new aluminum and steel battery with tap water, sodium hydroxide, and sodium percarbonate. And this is the new oscillator for this battery, and it's getting a very nice bright blinks. Let's see how long this will run. The battery now is sealed with well sealed with a wire here on the positive side, silicone sealing the openings, and the oscillator on the top. It produces a lot of bubbles, and these bubbles really expand. I did not know why, but I removed water 2 times from this can, and I lowered the level of the water, and the water rises again, level down again, and then on the second time I sealed the top of the can with silicone. The LEDs now are glowing much stronger. They are always glowing. And last time I measured the voltage, it was 0.7 volts on this battery. So it's aluminum can with sodium hydroxide and sodium percarbonate, sodium percarbonate. I'm sorry. And I think that it is not needed the sodium hydroxide. Just the sodium percarbonate will be enough to produce this this amount of voltage, and in my opinion it will be the same power as this one. I have another can here. This type, it will be just sodium percarbonate, and I'll make the test to see if it have the same amount of voltage. And I'll make another battery with the same material, aluminum can, the same type of steel, and this time will be only water and Epsom salts. It will be one from sodium hydroxide and percarbonate, sodium percarbonate, another one just with sodium percarbonate, and the third one just with water and Epsom salt. The oscillator circuit will be the same. I'll try to maintain the same size of coil, the same values of the components and everything. Today, this battery was made on 20th, 3 a.m. Today is 21, it's 5:20 a.m. and it's running for 24 hours.